So we are doing the Module 3 test review. And first you're given a graph, and we need to figure out what the relation is. Remember, the relation is the set of ordered pairs. So I'm going to make a set. Okay, so these are going up by 2s. These are going up by 1s. So 2, 2 is our first point. And then we have 3, 6. And I might have to make this a little bit smaller. There we go. And this is 5. So we have 5, 8. We have 5, 10. We have, oops, I didn't mean to write 5. Then we have 6, 16. We have 8, 12. And 8, 18. 8, 12. Oops. 8, 18. Last but not least, we have 9, 14. Okay. Now from that, we need to come up with the domain. So the domain are all the x values. So, I don't know why I did that. 2, 3, 5, 6, 8, and 9. And I put them in numerical order. And then I have 2, 6, 8, 10, 12, 14, 16, 18. And they're in numerical order. Now, is it a function? Well, we have a problem here, Houston. We have repeating x values, so that means that the input doesn't go to exactly one output. So no. The input goes to more than one output. Is it discrete or continuous? It is discrete. Even though it's not a function, it is discrete in the fact that it only has the dots. It doesn't have any kind of line. Okay, so then we go to this next one. It says a local library was selling some discarded books. Daniel collected data to determine the number of books people bought and the price they paid for those books. Let X be the number of books. X, so this is number of, I almost put good books, number of books, and Y be the number, so this Y is Y, and money paid. Okay. What does the independent variable represent? Oh, I just wrote it over there. The number of books. What does the dependent represent? The money paid. Relation. So I write it as ordered pair. So 1, 2, 2, 0, 2, 10, 3, 6, 7, 4, 8, 6, 9, 4. Okay. So now, is it a function? No. Why is it not a function? Because if you look at this, 2 goes to 2 different outputs. No, because the input 2 has 2 different outputs. Is it discrete or continuous? This would be discrete because you are not selling half of a book. You can't or shouldn't sell a partial part of a book. You may do that on the online books, but you don't do that on regular books. Money. Amir's average cost of taking a taxi to work has steadily increased over time. The average cost of taking a taxi to work is the blank variable. Time is the blank. So if I was to make a graph, down here is my time. Over here is my money. So time is the independent. The amount of money depends on how much time is spent. Okay, so we're going to use the graph for this part. Area 1. Okay, so we know area 1 is increasing, but what's it increasing in? Let's look at it. So we're talking about the volume of air in a balloon. So as time is going up, as it's increasing, the air is getting to be more and more. Okay? So as the time increases, the volume of air increases. Area 2, I'm actually going to change color. Maybe. Okay. Area 2 is this part right here. Okay. This is my maximum. Oh, I can't even spell today. This is my maximum point. It's not a relative maximum. It's the actual top of the graph. It is my actual maximum point. At a certain time, the balloon stops being filled or I guess I could have said is totally filled. Then this last part going down, that part is decreasing. What does that mean? After the maximum amount of air, the air is being let out until there is no more air in the balloon. Okay, so let's look at this next one. So the table and graph show the number of pounds of bananas sold at the local grocery store from 2013 to 2017. Okay, so if I'm looking at this, what does the x-axis represent? And this is going to be years since. And what year did we start with? We started with 2013. So that's going to go, and it has a scale of 1 year. Then, what does the y-axis represent? Okay, so this over here is going to represent the number of pounds. And I don't really know why I drew this circle thing. I don't even have enough room. The number of pounds sold. And that's in the thousands. There we go. And that's going to be, and it has a scale of 10. Now, the thing that's not on here is I want to talk about the origin. What does the origin mean? We're at 0, 0. So the x value represents the year since 2013. So when x equals 0, that is 2013. When y equals 0, that means no bananas were sold. Okay, is it a function and why? If I look at this, yes. Because all inputs correspond. I should not put all inputs. I should put, because the inputs correspond to exactly one output. Not meaning they go to one number, just meaning, oh, how about we do this? Each. There we go. I like that. Each input corresponds to exactly one output. There we go. Sounds much better. So I have a -2, an 8, an 8 up. Those repeat. So no. Because the input of 8 has more than one output. Okay, over here. I don't know why these are all weird. The domain doesn't repeat itself, so yes. Each input has exactly one output. Okay. Dr. Ombre recorded the names and the ages of the patients she treated for influenza today in her office. The names and ages and years are as follows. Okay, write the domain and range. So the domain of this would be their names. Their range would be their ages. So the domains. Leona, Thomas. Oh, I spelled Thomas instead of Tomas. Jerry, Melanie, Bailey. I think I needed a longer name or a longer thing. There we go. And then my ranges would be going in order. So 32, 38, 45, 52, 61. And is it a function? Yes. Because you can only be one age at a time. Okay. Is it discrete, continuous, or neither? Discrete, continuous, continuous. Notice how it didn't say is that they're all functions. I just almost wrote continuous. Well, I forgot to answer the question, is it a function? So this is function. This is a function. This is not a function. And this is... Why did I say neither on this? Why did I say neither? This is continuous. Don't ask. Don't ask. Okay, so because blue's my favorite color, we're going to go back to blue. F of 2. So I'm going to replace the x value with 2. Negative 18 plus 8. So negative 10. Now, on this one, I'm actually going to replace... I'm going to do g of 3 minus, and then I'm going to change this one to g of 4, just so that you can see me plugging in. So I'm going to take negative 2. I'm going to replace the x with 3, plus 3, and then I'm going to subtract, and I'm subtracting this whole thing. So I'm going to take negative 2 times 4, and I'm going to add 3. Okay. So g of 3 minus g of 4 equals, so this is going to get me negative 6 plus 3, and I'm going to have minus negative 8 plus 3. So I would have negative 3 minus negative 5. So g of 3 minus g of 4 equals 2. And then last but certainly not least, f of 5 minus g of 1. So f of 5, so I'm going to take negative, nope, I didn't change the color back. No. Oh, Kimberly. Negative 9. Okay. Having a hard day this morning. Negative 9, I'm going to replace that with 5. And I'm going to add 8. And then I'm going to subtract. And that's negative 2 times 1 plus 3. So that's negative 45. plus 8 minus negative 2 plus 3. So f of 5 minus g of 1 equals negative 37 minus 1. So f of 5 minus g of 1 equals negative 36. Okay. The company that sells nutrients for soil uses this graph to show how one of its products releases a nutrient over time. Use the graph to determine the function that models this relationship as discrete or continuous. So it is continuous. Draw in the picture if it has a relative maximum or minimum. Right here we have it's actually a complete maximum. Label the increasing and decreasing portions. So I come here. I'm going to do this. This part is increasing. This is the increasing part. And then we'll do pink. Now, it kind of does a little thing, but all of that is the decreasing part. Okay, it was decreasing faster up here and slower down here, but there it's all decreasing. Okay, a number cube is rolled. The results are recorded in the table. Use the table to determine whether this models a relationship of discrete or continuous. Since you only have 6 sides to the die, you don't have in between things, it is discrete. You only have 6 choices. You cannot have numbers in between each side. Okay, standard form. Remember, standard form is ax plus by equals c. A, B, and C are integers, and A is not negative. Okay? So, first things first, it has to be an integer. So I have to get rid of this fraction. So the common denominator is 3. So I'm going to multiply everything by 3. 3 times negative 2/3 x equals 3 times 10y. 3 times negative 2. So this is going to give me negative 2x equals 30y minus 6. I've got to get the variables on one side, so I'm going to subtract 30y, get negative 2x minus 30y equals negative 6. We said that we can't have a negative number as the a value, so we're going to multiply by negative 1. And I'm going to get 2x plus 30y equals 6. Okay. Over on this one, what's the common denominator on this one? Common denominator is 4. So I'm going to multiply both sides by 4. If I do that, I get 16x minus 48 equals y. So I'm going to add 48. So I get 16x equals y plus 48. I'm going to subtract y to the other side. 16x minus y equals 48. Okay, is it a linear function? So let's multiply this through. 6y minus xy equals 6. To be linear, we have to have it, I don't know why I forgot the m. Should look something like one of these two. That does not look like that, so no. Let's look at this one. 2y equals 3 minus x plus 6. 2y equals negative x plus 9. If I was to divide through by 2, then yes, that is linear. And just for you, I'll divide through. Okay? On this one, these have squareds. No. Right here, this has the y in the denominator. No. Now this has this in the denominator, but these can cancel out. So I could have this, and I subtract d over 5 equals, I don't know why I wrote d there, 2 d equals 10. Yes. As long as d is the y, I shouldn't say the y, I should say the dependent variable. Oh no, it doesn't even matter on that. It could be the independent, or they just wouldn't be a function if it was the independent. So yes, because it would still make a line. It would either make a horizontal or vertical line. So that's good. Use the graph to estimate the x and y intercepts. So the x-intercept is going to be 1, 0. The y-intercept is going to be 0, negative 3. And then it says, describe the function is positive or negative. Okay, so this part right here is positive. So that means when x is greater than 1, so that's going to be 1 to positive infinity. And then down here, this part, when x is less than 1, so from negative infinity to 1. Okay, a garden supply store manager found that she used a certain function. She could determine the price to charge for the shovels to maximize the store's revenue. The graph represents the revenue of y, so this is the revenue, so the money that the store earns, and the price per shovel in dollars. So the x-axis, or the independent, is the cost per shovel. Use the graph to find and interpret the line of symmetry of the graph of the function in the context of the situation. I added a few more things to it. So let's look at this. So the line of symmetry is right here. So the line of symmetry is x equals 40. Okay? So x equals 40. When x equals 40, the store will earn the most amount of money. This is a maximum value. What is the maximum? Let's see, $5,000. The most the store will earn is $5,000. Okay, so what is the x-intercept on this? Okay, so I see 0. So I see a 0 here. I see a 0 here. I see a 0 here. Remember, x-intercept is when the y value is 0. Y-intercept is when the x value is 0. So this first one, -2, really? I totally put it on the wrong one even after saying it. -2, 0 would go there. 0, 8 would go here. And 2, 0 would go here. And that's a quadratic, by the way. Football. The graph shown is the height of a football after being kicked. Use the graph to answer the following questions. What is the x-intercept? So x-intercept is down here, 5, 0. What does that mean? After how many seconds? 5 seconds. The ball is on the ground or hits the ground. Okay, the next one, what is the y? Oops, I almost started writing the sentence. That's 0, 6. The ball is kicked at a height of 6 meters. What is the relative max or min? It's really the total max, but this book is weird. So now let's look at that. I just did that. So really the max is probably about right here. It's not quite on that dot. So I'm going to say at 1.8, comma 9.3. These are just estimations. What does it mean? At approximately totally misspelled approximately 1.8 seconds, the ball is at the highest point, the highest point of 9.3-ish meters. Don't know why I put a parenthesis. Where is the graph increasing? So we're talking about increasing. So this part right here, the graph is going up. We're going left to right, it's going up. So x is greater than 0, but less than approximately 1.8. So it's between here. Really? Kimberly, you would think that I taught math. It's from 0 to 1.8. You would think that I knew what I was doing. I'm going to do here. Then it's oops. I meant to do red of the highlighter. Okay? So, when x, I did it again. X is between 1.8-ish and up to 5 seconds. So it's between 1.8 and 5 seconds.